Hello everyone, welcome to the class. Let's see one problem. So we will solve this, we will try to solve this problem in a detailed way. So we will use KVL and we will not use any shortcut here, or maybe we will use or see any kind of shortcut later, right? So okay, so here you can see there are two capacitors which are connected to each other through a resistor 1 ohm, and the initial conditions are given like V1 is initially charged to 2 volts and V2 was initially charged to 1 volt, and after that we are switching at t is equal to 0, and here we want to sketch this V1 as a function of time, this V2 and this IT, right? Okay, so let's solve it. Okay, so first let's close the switch. Here the switch is closed. Okay, and this is how the current is given. This is plus minus terminal, this is plus and minus terminal. Actually this terminal is already given in the question, V1 and V2, so we will not change the terminals, that is the polarity. We will not change the polarity, we will keep the polarity same as it was given in the question. Okay, this is V1 and this is V2 and this is R, this is C1 and this is C2, right? So let's see what is the relation of IT and V1T and IT and V2T, right? Okay, so before just writing it, so there is a convention. Let me use this green color. So suppose this is plus terminal and this is minus. If this is the polarity of this capacitor, suppose this is capacitor, general capacitor, and this is how the current is flowing, right? If it is going in the plus terminal, so you need to write like this way: I is equal to and C dVc by dt, right? Okay, so using this, let me just put in a square bracket. Okay, we will use this convention. Okay, so let's use this convention for V1 and IT. Okay, so as we can see, I will be minus C1 dV1 by dt. Why there is a minus sign, right? Because if you see, this is a plus and this is minus, and this current IT is coming from down, right? This way, this is I, so the direction is like this, right? So this current is going into minus terminal and coming out of the plus terminal, so that's why I have kept this as minus, right? And for okay, for V2 and I relation, so it will be a direct relation because C dV2 by dt, right? If you see, because here this current is coming like this way, na? Yeah, this is going this way into positive terminal. So for I and V2, it is a straightforward equation. Okay, fine. Okay, so so what is the other step? So if you integrate, okay, let's take this as equation number 1. So what will be the next step? If you want this if you want to calculate VC in terms of I, so let's integrate both the sides, right? So this will become like dVC by dt is equal to I by C, and dVC will become I by C into dt, and if you integrate it, Vc will become minus infinity to t I by C dt, right? And if Vc is the C is constant, capacitor is constant. Okay, Now you can see I dt. So this is how you can write Vc in terms of I. Okay, let me again just put it like this way, right? Okay. The same thing will happen here also. So if you see V1, so V1 will be like minus 1 by C1 I dt minus infinity to t, and V2 will be equal to 1 by C2 minus infinity to t I t. Since I is common for both this capacitor, that's why I is appearing in both these equations. Okay, V1 and V2t. Why I have written V1 and V2? Because when we solve, means when we apply a KVL, right, there is nothing like KCL in this. There is a loop. So in KVL we need the voltage terms, right? Okay, so if I need to write, this will be like plus V1 and minus IR and minus V2. This is going. Okay, so I need to go like this is plus V1 minus IR is equal to V2. I think I have written correctly. This is plus V1. Okay, I'm going in the direction of IT. So this is plus minus IR, there is a voltage drop plus and minus, okay, minus IR, and again there is a voltage drop minus V2. Okay, fine. So what is V1? Minus 1 by C1 minus infinity to t I dt minus IR is equal to, what is V2? 1 by C2 minus infinity to t I dt. Okay, so there is a whole integration term. So let's differentiate this equation. Let's what is this equation number? Okay, here I have written 1. Let's give it to equation number 2, right? Okay, if you feel any doubt, please drop a comment. Okay, so what will be this one? Okay, if you integrate this will become minus I by sorry, that's okay, minus I by C1 minus di by dt. I'm differentiating with respect to t time, right? This is R is equal to 1 by C2. Okay, this again is I. Okay, now it has become this first order differential equation. Yes. Okay, so let me arrange all the terms to one side. So I think it will become di by dt. You see R plus I by C1 plus I by C2 is equal to 0. Let me divide this equation by R. If you see I, let me take I common, R is there. 1 by C1 plus 1 by C2 is equal to 0. Okay, so what is 1 by C1 plus 1 by C2? 1 by C1 plus 1 by C2, it will become C1 plus C2 upon C1 C2, right? So it will be equal to 1 upon C equivalent. I'm just trying to simplify this 1 by C1 plus 1 by C2 terms. It has become like 1 by C equivalent, so I can write it R into C equivalent, right, equal to 0. Now this has become very simple differential equation, right? This has become a homogeneous differential equation. You can see there is no term present on the RHS side. Homogeneous, I think my spelling is wrong, sorry for that. Homogeneous differential equation. We can directly calculate the value of I. So generally it is written like d plus 1 by RC equivalent to I is equal to 0. So generally what is the solution of this equation? It is straightforward. This I of t. Okay, let me write it like I. So I will become some constant a e की power. What is the solution? So d is equal to minus 1 by r equal, sorry, this is r into c equivalent, r into c equivalent, right? So it will become minus t by r into c equivalent, right? This will become okay. So this is the sketch of I, but still you see we don't know the value of a. So from previous lectures we know that to find out the value of a, we have to go back to the circuit and see the initial conditions, right? So okay, so let's draw the circuit, because okay, how we can calculate, okay, why this initial conditions? Because see, there is only one way to calculate the value of a. If we put t is equal to 0, the whole term will this whole term will be like 1 and only a will be there, right? So that's why we will look for only initial condition, that is at switching instant. Okay, so at switching instant, let me draw with this blue color. Okay, at t is equal to 0 plus. So okay, again there is a resistor in the circuit in this path, so capacitor will not allow sudden change of voltage, right? So here again VC2 0 plus will be like 1 volts, and VC1 0 plus is equal to 2 volts. Why I'm writing 2 volts and 1 volts? Because here, and you can see, just in the, it is given like V2 was 1 volt and V1 was initially it was 2 volts, right? So it is already given in the question. So we will use, and we will apply a KVL here. So it will become like 2 minus I of 0 plus into R is equal to 1, right? So it will become like I of 0 plus into R is equal to 1 volts. So I 0 plus is equal to 1 by R. Again R is equal to 1 ohm, so it will be like 1 ampere, right? Let me see, this is 2, this was 2 volts, right? Plus minus, and this is plus minus 1 volts. 2 minus 1 is 1 by R is again 1 ampere. Okay, so now I 0 plus is equal to 1. So at t is equal to 0, it will be like 1 a e की power 0. So a is equal to be like 1. So we have drawn, okay, not drawn, we have find out the value of a. This is simply 1. That's not the right value of 1. E की power minus t by, okay, R into C equivalent. Okay, so let's see what is R into C equivalent. So what is C equivalent? It was like C1 C2 upon C1 plus C2, right? So what was C1? I think 1 farad and 0.5 farad. 1 and 0.5. Okay, so C equivalent would be 1 into 0.5, 1 plus 0.5, that will become 0.5 divided by 1.5, right? So 1 by 3, 3 by 2, 1 by, this will be like 1 by 3, 3 by 2 and 1 by 2. Okay, this is 1 by 3 and R is equal to 1. So here I can write like this way, I is equal to e की power minus t by R. C equivalent will be, R into C equivalent would be, again it will be 1 by 3, and the unit will be in the time, 1 by 3. So it will be like 3t, right? So okay, minus 3t, right? So this will become the time constant. Fine. So this is like I. Okay, so this is the equation of I, and let's go for what was like, okay, v1 and v2 is like directly an integration, that is v1 is equal to minus 1 by c1. Okay, so let's go for v1. v1 is equal to minus 1 by c1 I dt minus infinity to t, right? Let's solve this and we will get the value of v1. So minus 1 by c1, okay, minus infinity to 0 dt plus minus 1 by c1 0 to t I dt, right? Okay, why I have divided this integral in two parts? Because see, our actual the response is starting from t greater than 0, right? Before switching it was like the capacitor was charged to this initial values, right? v1 was charged to 2 volts, right? And v2 was charged to 1 volt, right? So once the switch was closed at t is equal to 0, after that this I is starting, right? But now here, as you can see, this is very important part here. If you can see, this is the part, this is generally the initial condition part, initial condition, and this is like the, what should I say, the present means after switching, after switching part, right? Okay, so here I can directly write it, this whole part as v1 was 2 volts, I can write it directly 2 volt, this part, plus minus 1 by c1, right, 0 to t, and what is I, what was the value of I, e to the power minus 3t, e to the power minus 3t dt. I think I'm not making any mistake. Yes, okay, it was dying out again. So you can see again that the minus sign has to be there, because if minus sign is not there, means if it is a plus sign, so with time it will increase, and that cannot means happen, right? So it will increase to a very large value, right? So it has to be a like decaying constant, right? Okay, so let's solve it. 2 minus, what was the value of c1? c1 was 1 or 0.5 again, c1 is like 1, okay, c1 is 1, okay, so it will become 1, right? And if you solve the integration, e to the power minus 3t upon minus 3, 0 say t, again 2 is there, minus sign is there, okay, let's let's 1 by 3, right? Minus minus cancel, so e to the power minus 3t minus 1. So if I just solve it, 2 plus 1 by 3 e to the power minus 3t, and what is this, minus 1 by 3, so it will become 5 by 3 plus 1 by 3 e to the power minus 3t. Okay, so this is, this v1 response is, this v1t is complete response is like 5 by 3 plus 1 by 3 e to the power minus 3t. Let's see whether it is satisfying the initial condition or not. At t is equal to 0, initially it was charged to 2 volts. If I put t is equal to 0, so when you are solving the equation, it is always good to cross verify the initial conditions. So what will happen if I put t equal to 0? So t is equal to 0, this will become 1, 5 by 3, 1 by 6 by 3, 2 volts. Okay, again at least 2 volts, fine. So it was charged to 2 volts. Okay, so let me just, So this is the response of like v1t. This is the response. Okay. Okay, v1t. Now for finding v2, there are two ways, I think. Why I'm saying two? Because I will write it right now. I'm scrolling, it can confuse you, but I will write it again. Okay, so this one is the equation. See, the thing is that here already I have find out this I1t, and I have already calculated this v1t, so you can directly calculate v2 like this way. See, so what are those two ways actually? Let me draw the circuit once again. This was C1 part, this was C2 part, this was R, right? Okay, this was V1, this was V2. So I have written V2 is equal to V1 minus I into R. We have already find out this V1 and I. So V2 can be directly find it like this way. 5 by 3 plus 1 by 3 e to the power minus 3t, right? Minus I into R. What is I? This was I think where I have written, yes, this was I, right? E to the power minus 3t into R. R is again 1. So minus 1 by 3 e to the power minus 3t into 1, right? R is equal to 1 ohms. So here I can calculate V2 as, this will cancel, no ways. This whole term will be cancelled. No, this is not cancelled. Okay, sorry, I'm sorry. This is 1. Fine, this is 1, coefficient is 1. Okay, so the constant term will be same as it is, and what will be this term? Minus 2 by 3. 3, yes, minus 2 by 3. The thing is that whatever you have written, it must satisfy the initial condition. So what is the initial condition actually? So the initial condition will be like, it has to come 1 volt. So is it coming 1 volt at t equal to 0? This is 1, 5 minus 3, again it is coming 1 volt. So fine. If you see, this is the graph of V2. Right, so we have find out all the responses. Okay, there were two methods. Also you can find out V2 in a similar way. V2 was also equal to, means let me use the same color, V2. This V2 I have find out using this equation, right? Just let me, okay, this equation, because I have already calculated I1, I have already calculated V1. So V2 is like simply just subtracting V1 from subtracting IR from V1, right? V2 was also equal to, right, 1 by C2 minus infinity to t, right, I into dt, right, which can be written as 1 by C2 minus infinity to 0 it dt plus 1 by C2 minus infinity, sorry, this will be, actually this is how student make mistake. Fine, so this is again is the initial condition part. Condition part which was equal to 1 volts, right? You remember this was 1 volt. Okay, V2, and this part you can solve it. C2 की value 4.5 and this will become 2, 0, so t e की power minus 3t dt. So if you solve it, you will again get this equation. Definitely you will get this one. Maybe you can try it out. So there are two ways of finding this V2, right? So now let's draw the graph, right? The graph part. If you see I was starting from 1, and at okay, let me choose a different color, green one, right? Again it is exponential, it was starting from this value of 1 ampere, right? And at infinity it is going to towards 0, it is completely discharging, right? Okay, now let's draw v1 and v2 on the same graph. Okay, let's choose a color for, okay, let's start with v1. So v1 was starting from 2 volts and it was ending on t infinity 5 by 3 volts. So if you put t is equal to infinity, you will get 5 by 3 volts, right? So if this is like, let me draw a, suppose this is 5 by 3 volts, right? So here it was starting from 2 and it was going to approaching towards 5 by 3 volts now, and this is v2, this was v1, right? Now let's take this blue color. Okay, blue color for, so blue was starting from sorry, this v2 was starting from 1 volt, right? Initial condition was 1 volt, and again if you see at infinity it is coming to 5 by 3, right? It's coming to 5 by 3, right? And for v1 also, means both are converging, right? Both were approaching to the same value, same time constant, right? Okay, so this is the graph for, this is for v2, right? Again, and see, as the I is going to 0, both the voltages were settling at 5 by 3 volts, right? Okay, so in the previous lecture also, at last I have given you, means I have told you that this is how the response of the first order system looks like. It will start from some value and it will end at certain value, right? So now the thing is, now what I want to, so okay, so here the first way to solve is like you use a very subjective approach, means to you take a subjective approach. Here you just solve this KCL, or maybe here not KCL, we have not solved KCL, means KCL you will solve the KVL, and then you will solve the integral equation, then you will solve the differential equation, and you will apply all those initial conditions, and then you will get the final complete solution for v1t, v2 and it, right? You'll get the response like this, fine. So is there okay, so the thing is that as long as the DC source is present in the system, the response will the response of any, means the response of current, the current response or the voltage response will look like this, means it can be easily drawn if you know the initial and final condition and time constant. Okay, so the key point is like, if you know the initial condition, if you know the steady state value, and third part the time constant, you know, if you know these values, right, you can directly you can write the equation for first order circuits, like, and this will, I have already given the previous lecture. For example, for case of voltage, you can write like this: v of infinity plus v of 0 plus minus v of infinity, right, e to power minus t by tau, time constant, right? So if you know this final value, steady state value, initial condition, and final steady state value and time constant, you can always draw the graph. And same thing is there for I of t, q of t and psi of t. Psi basically the flux, right? Generally in engineering questions, v, I and q are asked, psi is not asked, but again it applies to all these 4 parameters, right? Okay, so let's approach the same question using this method. Means if I know the initial condition, the steady state, time constant, I can, let's solve this. Okay, fine. So our question was like this. R is equal to 1 ohm, C1, C2, initially it was charged to 2 volts, initially it was charged to 1 volt. So initial condition is already given, right? Okay, what is the time constant? How to calculate the time constant? So in the previous lecture also I have mentioned that it is like R equivalent into C equivalent. So what is R equivalent here? What is R equivalent here? There is a single loop. R equivalent is simply R. And what is C equivalent? Now here the two capacitors are in series. So for series capacitance we find the equivalent capacitance like this way: C1 C2 upon C1 plus C2, right? Okay, so there was a formula like something I can remember, or maybe you can find it out. If C equivalent is there, if multiple capacitors in series are there, 1 by C1 plus 1 by C2 plus 1 by C3, like that, right? So here we have only two capacitors, so C equivalent will be like simply C1 C2 upon C1 plus C2. So that we had find out, I think 1 into 0.5 upon 1 plus 0.5, that is equal to, I think, how much? 1 by 3, right? 1 by 3. Yes, it was 1 by 3 and it is equal to 1. So tau is like simply R into C equivalent. It was like 1 by 1 into 1 by 3 equal to 1 by 3. Tau is equal to, right? So initial conditions is okay, and we have also find it we have figured out this value of time constant. And now let's go for the final values, steady state value. So how to find the steady state value? Okay, if you see initially, okay, so here we have to means in steady state what will happen? Steady state, so in steady state the current means the capacitors will be charged and there would be no current actually flowing in the circuit. So basically this voltage and this voltage has to be same, right? This, suppose this is VB node and this is VA node. So in steady state, VA is equal to VB, then only I will become 0, right? You remember we have maybe we have drawn the curve of I, and it was in steady state, it was going to 0 in the steady state, right? This was time, this was like from 1 ampere, this was I, right? It was going to 0. So 0 means definitely V and VB has to have to be equal, right? Okay, so let's call V and VB is equal to, in final state, let's call it phi. Okay, VA is equal to VB is equal to VF, the final state or the steady state, right? Okay, so initially let's see what was the charge present. So the charge present in the circuit would be the same, right? What was the initial charge in the system? Okay, it was at T is equal to the 2 volts and 1 volts, right? So 2 volts. So initial charge was 2 into C1, 2 into C1 plus it was 1 into C2, right? This is the case. Actually is Q1 plus Q2 is equal to Q final, will be same at T is equal to, means it was in steady state. Sorry, what actually I'm trying to write like is like this, wait, Okay, so the thing is that the charge present on this initial, okay, the charge is not going to anywhere. The charge will simply it will just redistribute. Okay, so charge at t is equal to 0 plus will be equal to charge in the system actually at t is equal to infinite, means steady state, right? So initially what was the charge, both this means on both this capacitor, 2 volt into C1 plus 1 volt into C2, right? And finally it has become Vf into C1 plus Vf into C2, right? Okay, so what is like 2 into 1 plus 1 into 0 0.5, right? So this will become 2 plus this will become 1 by 2, right? Is this okay? Fine. And what is this? This is Vf 1 plus 0 0.5. Okay. So what is Vf equal to? So Vf will become 5 by 2 divided by 3 by 2, right? This is 2. This will become 5 by 3 volts. Okay, so the steady state value for this capacitor would be like V and Vb will become 5 by 3 volts. Now this is okay, fine. Okay, so let's go for let's write the equation for V1, right? What is V1t? What is the steady state value? 5 by 3 plus the initial value was 2 volts, right? Minus 5 by 3 e power minus tau by t by tau, right? So we will write, and tau was 1 by 3. So 5 by 3 plus 1 by 3, right? Yes, 1 by 3 e power minus t, 3t, right? So this will become 5 by 3 plus 1 by 3. I think this is the equation we got, right, for V1t, right? You can check, because at t is equal to 0 it will be like 2 volts, and at t is equal to infinity it will die with 5 by 3 volts. Okay, fine. No need to cross verify, means using the equation I have cross verified actually. So what is V2? Let's see. V2, the again the steady state value is 5 by 3 value plus initial condition 1 minus 5 by 3 e to power minus 3 tau, sorry 3t, and this is 5 by 3 volts, 5 by 3 actually, and it has become 3 minus 2 by 3, right? And e to power minus 3t, so it has become 5 by 3 minus 2 by 3 e to power minus 3t, right? Okay, so this is like again at t is equal to 0, ये 1 volts हो गया, and at t is equal to infinity it will, okay, 5 by 3 volts पे converge हो रहे थे दोनों. Okay, so we got V2 is also, and if you see IT value, what was the initial steady state value? Steady state में 0 था because it was dying, plus steady state में what was the initial condition? Initial condition में 1 value थी, again 0 e to power minus 3t. Fine. So you can see e to power minus 3t I of t. Now, so in the second method, we just saw, without solving the differential equation, if the system is the first order, without solving the differential equation, we came to know the means we were able to directly write the equation, right, for t greater than or equal to 0. It is that simple, right? So the key point is that, right, so the key point is that if your differential equation is like, means a dy by dt plus b yt is equal to c, some constant, let me write it constant. If this is your differential equation, no, right? So the thing is that your response is always going to start from an initial value, and it will approach to a final value, right? And the response will always be exponential. This response will always be exponential, right? For first order equation, this is first order equation. Right, even by looking at the circuit you come to know that whether it is a first order circuit or a second order circuit or maybe higher order circuit, right? So if you know the initial value, okay, so this is, I want to say, this is the time axis. Suppose this is your response, it can be again voltage, charge, current or flux. You always need to know what is the, suppose this is your initial value and this is your final value, right? So you need to draw like this, right? This will always go like this way, right? This is initial value, this is initial point, this is final point, right? You can directly draw the graph like this. And again you have to find out the what is the time constant, at what rate it is decaying, right? Or what rate it is rising. So for that you need to know the time constant tau. It is always equal to R equivalent and C equivalent, right? So we will go through more questions like this, right? But certainly we will not solve this differential equation. If it is required, then only we will solve, right? So okay, so if you have any doubt in my explanation, and if you feel any if you have any query, so please drop down, please write down your queries in the comments. Thank you.